Hi everyone, this is just part 2 of what we started in part 1. We're going to solve simple trigonomic equations that are linear in form, and this is part 2. And you just solve it like you would a normal equation. We're going to subtract 3 from both sides, and we're going to get 2 sine of theta equals -1, and then divide both sides by 2, so you get sine of theta equals -1/2. And what I forgot to put, we want to solve on the interval from 0 to 2 pi. I'm going to go ahead and write the general formula for this. We already know there's 2 angles from 0 to pi, so I'm going to go ahead and write it that it's going to be 7 pi over 6, and the general form would be plus 2k pi. And my other angle is 11 pi over 6. And I'm going to write plus 2k pi, because that's going to lead into our next video. But we only actually have 2 solutions from 0 to 2 pi, and that would be 7 pi over 6 and 11 pi over 6. And you can see that from the unit circle. Alright, now the next one is we have 2 sine of theta plus 1. And basically it's the same, it's the same problem. Subtract 1 and divide by 2. So it's basically the same problem we had before. And again, all of these are from 0 to 2 pi. So our answer would be 7 pi over 6. This is our solution set. And 11 pi over 6. Okay, we have cosine of theta is going to be -1. So we have cosine of theta. I just subtracted 1 from both sides. And if I just write a general formula, that would be pi plus 2k pi. But we only have one solution, and that would be pi. There's only one place on the unit circle where cosine of theta is -1, and that's at 180 degrees. And we have tan of theta equals -1. So on this one, we know that the period for tan is pi, or 180 degrees. So we're going to go ahead and put our general form. This is where k is any integer. In this case, if you've been doing enough trig so far, you know there's 2 solutions where tan is -1, and that's in quadrant 2 and quadrant 4. Tan is negative there, and there's 2 of those. Those are the 45-degree type angles. And now we have cotan, so we're going to go ahead and subtract the 1. So, and then divide by square root of 3. And we know that's equivalent to square root of 3 over 3. And for that one, the solution is at 2 pi over 3. So we have theta is 2 pi over 3. And I'm putting just k pi because cotan is also, the period is pi, or 180 degrees. And our 2 solutions in this case would be 2 pi over 3 and 5 pi over 3. Okay, because we only can go from 0 to 2 pi. Since we have 3's here, we can't go higher than 6 pi over 3, because that equals 2 pi. Alright, and for secant, we are going to subtract the 6, and you're going to get -8, then divide both sides by 4, and you get -2. And so on the interval from 0 to 2 pi, our solution set is going to be 2 pi over 3 and 4 pi over 3. All right. The next one, same kind of thing. I'm going to add the 3 to both sides. Divide by 5, so I get cosecant of theta equals 1. And on that one, we know cosecant of theta is 1 at pi over 2. We're going from 0 to 2 pi, but if I write a general formula for cosecant, the period is 2 pi for cosecant, and so I know my answer is 2 pi over 3 plus 2k pi, where k is an integer. Or we could have what? No, it's cosecant, so it's just this one. So k is any integer, and then so our solution set in this case is just going to be, it's pi over 2, sorry. I'm looking at the wrong one. Looking at the one we just did. All right, so my solution set is pi over 2. All right, we have 2 more. I'm going to subtract the 2, so we get 3 square root of 2 cosine of theta equals negative 3, and divide both sides by 3 square root of 2. That's going to equal negative 1 over square root of 2, because 3 divided by 3 is 1, and we know that's equivalent to negative square root of 2 over 2. And we know there's 2 solutions where cosine is negative square root of 2 over 2, and that's going to be in quadrant 2 and 3. And these are actually the easier ones to me, so that's going to be 3 pi over 4 and 5 pi over 4. Again, we are going from 0 to 2 pi on these. All right, and the last one, we're going to subtract 3 square root of 3 from both sides. When you get this and you subtract those two, you get negative 2 square root of 3. Now let's divide both sides by 4. And that's going to give you sine of theta equals negative square root of 3 over 2, because 2 goes into the 4 2 times. And we know there's 2 solutions for this. Sine is negative in quadrant 3 and 4, and that occurs at 4 pi over 3 and 5 pi over 3. Okay? The next set we're going to do includes angles. We're going to restrict the solution set from 0 to 2 pi, but the arguments are different than just theta, so we have to solve for theta first. Thank you and have a nice day. Bye-bye.